Hey everyone, welcome back to Math with Mr. Miller. I'm going to be going through some Pearson's and Spearman's correlation coefficients, going through the difference between them, how you find them, that sort of thing. To start off, though, we do need to just talk about the way we describe correlation, especially in respect to a scatter plot and whether or not it's positive or negative and the strength of that correlation. So the strength of the correlation is typically described by one of three words, and that is either going to be strong, moderate, or weak. And visually, you can typically tell somewhat well. So we would consider these strong because of how close they are to the line of best fit. Or we would consider the graphs on the bottom probably weak just because the data is a bit more spread out and not as close to that line of best fit that's drawn through them. Um, or we could have moderate where it's, a good combination of the middle of those two graphs. It really just depends. But sometimes when you're looking at a graph, especially one that has outliers on it, it can be hard to tell whether or not it is considered strong, moderate, or weak, which is why we also have Pearson's correlation coefficient, which gives us a numerical representation of the correlation between two data sets or between bivariate data. Bivariate data just meaning two variable data sets. And we have a table. This table comes from our textbook that we use in my class. Every book kind of tends to have a slightly different table. It really just kind of depends what book you have, but they all kind of mirror this one somewhat. When it comes to the IB exam, either the correlation coefficient that you get, it'll be pretty clear whether or not it's to be strong, moderate, or weak. I.e., it'd be very, very high, or it'd be very mid-range, about zero point 0.5, or it'd be very, very low. Um, or what I've seen them do before on the IB exam is they actually give you a data table, or sorry, a table like this one where they describe what they want you to call the correlation in terms of strength based on the value you get. It really just depends on the question on the IB exam. But in this case, if you get an R value, your R value will always fall between 0 and 1 numerically. And then it could be positive or negative values depending on where your graph is going. So, for example, if it is going up and to the right, that's a positive correlation. If it's going down to the right as you read left to right, that is a negative correlation. Um, but once you get your R value, then you can determine really is it positive or sorry, is it strong, moderate, or weak? And I will say these are absolute values of R. So, for example, sometimes students get confused when they see a negative correlation. They think, oh, that's less than 0, so it must be weak. That's not true. It is how close that number is to 1 or how close it is to -1 that determines the strength of that correlation. So, -1 would actually be a very, very strong correlation. It would just be a negative descending like it is in this graph here. Okay. On the next page, we're going to kind of review some data as well as determine how do you find Spearman's versus Pearson's correlation coefficient. But if you need to copy anything down, feel free to pause the video as we go on. Here we have a data set, and we're going to go ahead and find Pearson's correlation coefficient, and we do so just using the raw data itself. So I'm going to take Pearson's correlation. Okay. And I'm going to use the raw data. Now, you need your calculator for this. There is a formula that you are able to use. That formula is not provided to you in your formula packet, so I really wouldn't recommend using it. You always have your calculator with you in IB Math AI applications interpretations, and really the calculator is going to be your best bet for finding Pearson's correlation coefficient here. So I'm going to go ahead and get that now. I'm going to pause the video. I'm going to calculate it myself in my calculator and then write the value, I would go ahead if you want to make sure you recall your calculator steps from class, pause the video and calculate it yourself. So in this particular case, I end up with a Pearson's correlation coefficient of 0.7514. And I should say, I'm going to round that to three significant figures. That is an ongoing value. So three significant figures in this case would be 0.751. Well, that falls on my chart just slightly above that 0.75. So this would be considered a strong correlation. And in this case, my R value is positive, so strong positive. Um, what a lot of the times the IB exam will do, it's not uncommon that this is worth 2 points on an IB exam question. And so what I would always stress is just double check that you plugged your points in right, or sorry, your data in correctly into your table, because I would hate for you to lose multiple points because you just typed something in wrong. And frequently, the follow-up question to getting this correlation value is they will always typically write something like comment on your result as the next step to this IB exam question. And really all they're asking for is for you to describe the correlation as strong positive, maybe linear depending on if they ask for it. But in this case, this is almost always typically 2 points, and it's just strong positive would be my answer here on the IB exam. 1 point for each word there. If they ask me to interpret the data set, so interpret the result, okay, that is slightly different. They're asking you to put it more in the context of the scenario. In this particular case, I don't quite know what the scenario was. These probably, given that the first column there is student, these are probably test scores of some kind. Um, so in this case, whatever my x variable would be, let's say it's math scores. I would say as math scores increase, let's say the y scores were the science test scores for that student. The science scores um, also increase. And I will say we should probably qualify that a bit because I do want to stress when it comes to correlation, correlation does not equal causation. Just because you get one thing doesn't mean the other thing will happen. So we might want to add in a word here. So as math scores increase, the science scores also tend to increase. Gives that little ambiguity there. Now, um, let's say this specifically had asked us to find Spearman's correlation coefficient. We'll talk in a little bit about how you know, especially on your IA, which one you should use. But I'm going to go ahead and erase what I have here. So if you need to pause the video, if you're taking notes or things, feel free to do so. But I am going to go ahead and erase what I have on my board. When it comes to finding Spearman's correlation coefficient, we actually call that Spearman's rank correlation coefficient. So if you want to call it by its full government name, the full government name for Pearson's would actually be Pearson's product moment correlation coefficient, but normally we just shorten that to just Pearson's correlation coefficient. Spearman's rank correlation coefficient, it actually kind of tells you what you need to do in the name there. The keyword there is rank. What we do is we actually rank our data either least to greatest or greatest to least before we calculate the correlation coefficient. So what I have to do first is I actually have to order these, and when we actually rank them as if they were like winning a race. So I'm going to look for, if I'm going to do this least to greatest, I'm going to go and look for my smallest value, and I'm going to choose that 16 there. I'm going to rank it number one. And then I'm going to look for my next smallest value, which appears to be that 35, and I'm going to rank it. And you just kind of keep going up from there. So I'm going to go ahead and fill in the rest of the ranks here. If you want to pause, make sure you get the same ones. Feel free to do so. But I'm going to go ahead and add those in here now. So there would be the rankings for my first data set. For my second data set, I'm going to do the same thing. If I did least to greatest on my first data set, I need to do the same thing for the second data set. But technically, it doesn't really matter. If I had done greatest to least for the first one, doing greatest to least for the second one wouldn't get me anything different. You just want to be careful on the IB exam because if they have filled in some of the blanks for you, they might be indicating they want you to go from greatest to least or least to greatest. So just be caution. Take caution when you are doing an IB exam question if they've filled in some of these rankings for you. So my lowest value here is going to be that 25. And then I'm going to have, it looks like 44 is my second value. And what you might notice here is we actually have two values that tie. 45 and 45. Now, if this were an actual like race, both those values would get the same rank. And that's going to be true here too, but they would both in this case get a rank of 3, which is not what we do for Spearmans. Instead, what we do, they both together would have been ranked 3 and 4, but we don't really know which one should have been 3 and 4. So instead, we take those values and we average them. And they're both going to get 3.5 as their rank. Okay. So we average the values in order to give them the same rank. And here's where a lot of students will accidentally trip up. So if you think about the way a race works, if let's say two people come in first, they're both given the same rank of first. That's where Spearman's differs a little bit. They wouldn't be given the same rank of first, but in a race, they're given the same rank. The next person that finishes, that third person that finishes, is not then awarded second place. They're still awarded third because they came behind two other people. Spearman's does the same thing. So because I awarded both of them 3.5, 3.5, they really would have been ranked 3 and 4. I have to just keep continuing on. I'm going to skip over 4 and go on to 5. So 45, 45, my next smallest value looks like it was this 57. So that 57 is going to be ranked 5. So you'll notice I don't have a rank 3 and I don't have a rank 4 at all. And a lot of the times I accidentally see students forget to skip over one of those values and still give something ranked 4. And then I can finish out the rest of my rankings here. It doesn't look like I have any more overlap. So it looks like rank 6 would be that 69. Rank 7 is the 74. 8, 9, 10. Once you have your rankings, you do the same calculator steps in your calculator. You put the rankings in as your data, and then you calculate it as if it were Pearson's correlation coefficient. But because you ranked the data, it is now technically giving you an R value that represents Spearman's. And in this case, if I calculate my R value, I'm going to give it a little subscript S because it's Spearman's. I would go ahead and type into your calculator to make sure you get the same thing that matches. So if you need to, go ahead and pause the video while you calculate it, and then I will put my value up here on the screen for you to be able to check your answer. And when I calculate my Spearman's rank correlation coefficient, I get 0.7173 dot dot dot. If I round that to 3 significant figures, I'm getting 0.72, or sorry, 0.717 as my rank correlation coefficient. And again, we describe it the same way. So frequently the next question on the IB exam would be comment on your result. In this case, it would be a moderate, strong correlation. And if they asked me to interpret, it's a very similar sentence that I would write. Okay, I would say, I would have to throw in the word rank though, because I did rank everything. So as the rank, so I'm going to erase that the. So as the ranks of math scores increase, the ranks of science scores tend to increase. Okay, so keyword there is that I'm going to go ahead and rewrite that a little bit. My handwriting kind of threw off there. Yeah, not the best either. Um, so again, throwing in that rank is really the key thing when you're interpreting the Spearman's correlation coefficient in the context of the question. Now I'm going to go over kind of how you know when to use which one, because there are certain advantages to each. So I am going to go ahead and erase what I have the screen so I can write it out. So if you need to pause, feel free to do so. Otherwise, I am going to go ahead and erase it here in a second. Okay, so Pearson's versus Spearman's. How do I know which one to use? Okay, first rule, Pearson's is exclusively used with linear data. So exclusively used for linear data sets. So what we would do is we would go ahead and take our original data, all right, not the rankings for Pearson's. We would take our original data. And so all of our original here, all of our original here. And we would go ahead and put it on a scatter plot and we would check that that data falls in a generally linear pattern. If it doesn't, let's say it's falling in more of a quadratic pattern, that parabolic shape, or maybe it's falling in a logarithmic shape, that general curve, or maybe it's falling in an exponential curve. Um, you can typically tell if it's nonlinear just kind of by looking at the scatter plot. If it's falling in a nonlinear pattern, though, we would not use Pearson's. Pearson's is exclusively used when it comes to linear data. So what we would use is Spearman's, which can be used for linear data, but it has to be used for nonlinear. The other thing that's really helpful with Spearman's is because you're ranking everything, Spearman's actually does really, really well, or not, I wouldn't say really, really well, but it does better when there are outliers in the data set than Pearson's does. Pearson's can be greatly impacted by outliers in a data set. Spearman's, though, because of the rankings, does better than Pearson's under outliers. So Spearman's can handle outliers better than Pearson's. It's not as affected by outliers as Pearson's is. So if you know, oops, I'm misspelling Pearson's. So if you know there might be outliers in your data set, for example, in this data set, that 16 could be considered an outlier um, for one of our ranges, and maybe that 25 as well. It would really be best to graph it on a scatter plot and see if there's any really abnormal points on there before we really decided on any outliers. But if that were an outlier in my scatter plot, then I would likely go and use Spearman's instead of Pearson's, just because it won't be as thrown off. And again, if you all have any questions, please, please, please feel free to reach out. I'm more than happy to help. I will say I think every single year that I've been teaching IB, I have seen IB put a correlation coefficient question on the IB exam somewhere, whether that be paper one or paper two. So I wouldn't be shocked if they do so again this year. It's a very easy thing to ask. So they always typically put one or the other on the IB exam, sometimes both, depending on the question, if they want you to really kind of compare the two of them. So I wouldn't be shocked. I would definitely make sure you know your calculator steps to finding Pearson's and Spearman's correlation coefficient, as well as linear regression is also a common thing that they like to ask with Pearson's and Spearman's. They might ask you to find Pearson's correlation coefficient and then promptly ask you to find the linear regression, which we will cover in class and things as well. So if you have any questions, again, please feel free to reach out. Otherwise, thank you for watching, everyone.